Hi everyone, this is Dr. Sirisha working as Associate Professor in Institute of Aeronautical Engineering College. Here we are to discuss about stacks. What do you mean by a stack? A stack is a linear data structure. Then what do you mean by linear data structure? A linear data structure is nothing but a data structure in which data elements are placed in consecutive memory locations. Means if we are talking about integers and say that they need 4 bytes of memory. So if the first element is stored in location 2000, next will be stored in 2004, and the third element will be stored in 2008 location, fourth one will be stored in 2012 location, and so on. That means they are placed in consecutive memory locations, right? And then what is the difference between an array? Ma'am, you were talking about like this. Then what do you mean by array and the stack? What is the difference? Yeah, there is a huge lot of difference between these two. Array is a way of storing. Stack is a data structure. There is a lot of hell to heaven a difference between these two, right? I'm not biased about anyone. Array is one. Array is a storage methodology in which we store the elements in consecutive memory locations. And there are no restrictions on that. Do you have any restrictions on an array? You can delete the first element, last element, any element at a given position. You can do the same with deletion also. Delete the first, last, or delete the element at any position and sort it, search anything, any operation you can do. It is a basic template. I can put it as an array is a template, a generic method of storing the elements in consecutive memory locations. Yes. Then what do you mean by stack? Yes. Stack is a data structure. Data structure in which data is stored in consecutive memory locations, but there are certain constraints or rules when we use stack, right? So what are the rules? So if you can see the structure which I have displayed over there, you can see that I'm talking about 6 elements. So if I say that my stack will be of maximum size 6, the system is going to provide memory for 6 consecutive elements, right? 6 consecutive elements. And stack follows last in, first out methodology. Last in, first out. That means the element which is inserted into that, it is just like a bowl, a narrow bowl in which you are dropping the coins. If you want to pick or you want to remove, then you have to remove the latest one or the last one you have inserted inside it, right? You cannot take any intermediate coin or the coin that you have inserted first. No. Such a data structure is a stack. So it is also known as last in, first out methodology it uses. It is also known as push down list also we can call it as, right? So then how we know that it is what is the most recently inserted element into the stack? So for that sake we use the variable top. Top is the variable which holds the index value of the topmost element, that is the most recently entered element into the stack. Right now you can see that I have just said that the stack can have a maximum element 6. That is, I have confined its size as 6. Then I have not inserted any element into it. Right, I have not inserted. So by default, the top will be pointing to -1, saying that stack is empty. saying that the stack is empty, right? So this will be the rough sketch of a stack, an empty stack, right? So look at this one. So if I insert 25, my top will be pointing to index 0. Then I inserted 33. Top was pointing to index value 1, which is 33. Then I inserted 21. Now top is pointing to an element at index value 2, which is 21. Right? So top is going to increment itself by one step, and with every insertion, and it is pointing to the topmost element in the stack. Right? So what are the basic operations that we can perform on a stack? Push, pop, peek, is full, and is empty. These are the basic 5 operations that we perform on a stack. Then let's see each and every operation, what they mean by. What do you mean by push? Push operation is nothing but adding an element, adding or inserting an element into a stack. As I said, by default, the element that you are going to insert will be the recent element, or the element pointed by the top variable will be the result of any push operation. Okay, insertion. Simply you can say that insertion. As I said previously, I said that I have confined the size as 6. Stacks do follow that. Stacks have a limitation. We have to predefine the size of a stack. Right? We have to predefine the size of a stack. Yes, there will be condition. What will happen, ma'am, if I try to insert an element above the size? Say if the n value, which is the size of the stack, is say 10, and I started inserting the elements at, so the index values are going to run from 0 to 9. From 0 to 9, I have started inserting the elements, and at last, after 9, I started incrementing the index value and tried to insert it. Then a condition known as overflow rises. We call it as overflow condition. In general, in our correct language, what do we say? What do you mean by overflow? Something goes beyond its brim, right? So same words which they have picked and used over here. Overflow condition. If you try to insert an element in an already full stack, we call that an overflow condition has encountered. That is push operation. Second operation is pop operation. Popping is nothing but removing or deletion. What did I tell you? We have only one variable, top, which points to the topmost element. We don't have any other variables also to hold the remaining elements. No, we will not have anything in our hands. We will have just only top in our hands, which points to the topmost element. So even while deletion also, I can pop only the topmost element. When I remove the topmost element, top will be decremented to one step. Top will be decremented to one step. Generally saying that we can assume that the previously top element has been deleted. That is nothing but pop. Here also there is a precautionary condition. Why? I said that if the stack is empty, my top is going to point to -1. Am I right? When the stack is empty, top is equal to -1. Say there is a case where in our stack, only one element is there, say 5, its index value 0. What do you mean by this one? My top is pointing to index value 0, which is 5. And I popped it out. Once I pop it out, what will happen? Again, top will reach to its default position -1, which says that the stack is empty. My point is, what if I again perform a pop operation? That means a pop operation on an empty stack. That is an underflow condition. Then a error message saying that underflow condition raises. Underflow condition is nothing but a condition which tells you that the stack is empty. You cannot remove any element from it. Simple one, underflow. There is nothing to remove. And if you try to remove, it is saying that underflow. There is nothing inside the bag. Right? Inside the stack, you can say. Right? That is pop operation. Push is to insert an element. By default, any element will be inserted on the topmost place only. Second one is pop operation, that is deletion, where we remove the element pointed by the top variable only, the topmost element only. Okay, so at any point of time, stacks will be accessing with the topmost element, that is the most recently inserted element in the stack. We don't have access rights to the remaining elements in this stack. If you want to access the elements which are below the top, you have to remove the above ones only. That is the style of working of stack. Yeah, it is meant for many purposes. We'll see the applications of stacks. Then you'll understand why it is behaving like that. Okay. Let's say the third operation of pick tells you or displays or returns the element pointed by the top at any point of time. If you want to access or use the element which is most recently inserted, you want to check, then peek is the operation, right? Next two operations are isFull and isEmpty. isFull tells us to check whether the stack is full or not. And the next one is to check it is empty or not. It's very simple. If you are talking about is full, just check whether top is pointing to the last index value or not. Last index value. Say if you have n elements, if there are n elements, then if top is pointing to n minus 1, then that itself tells that stack is full. So always this isFull is a very useful function to perform push operation. Rather than getting an error message saying that overflow, just check first whether the stack is full or not. If it is not full, then perform the push operation. Okay, so the same point with your empty also. It is a condition to check whether stack is empty or not. Have to check top is equal to minus 1 or not. Just check this one. If top is equal to minus 1, that itself tells that top is at its default position, initial position is at its initial position, which tells us that stack is empty. This will be useful when you perform pop operation. Rather than getting underflow condition, guys, better perform isEmpty operation first. Check whether your stack is empty or not. If it is empty, then there is no point of popping or deleting, right? If it is not empty, then perform the pop operation. Okay, so these are the 5 basic operations that we perform on a stack: push, pop, peek, isFull, and isEmpty. Guys, I hope you understood this one. Okay, let's see stack operations. I'll show you the stack operations one by one. Okay, so let's take this one where the maximum size n is equal to 6. Let's say the n is the size of your stack. So the index values run from 0 to 5, right? And the initial value of your top is minus 1. What did I tell you? When top is equal to minus 1, it tells that the stack is empty, right? This is an empty stack. Now push 21 into it. Where it will come? It will be pushed to the bottom and it will be placed at index value 0. Index value 0 and top. What is the job of top? To point to the latest inserted element, right? So it is pointing 21. So what is the peak element in this one? 21. Again, push 15. So where it will go and sit? At index value 1. Again, top will be incremented. Now top is pointing to 15. And that is at index value 1. Now the peak element is 15 because this is the recently inserted one or the element pointed by top. Okay guys, take it. Peak is the element pointed by the top. Okay, now top is pointing to 15. So the peak element is 15. Right? So now I'm going to perform 13. I'm going to push 13, 24, 11 and 35. One by one. I've shown you insertion of 21 and 15. Now I have inserted 13, 24, 11 and 35. So top will be moving from one after the other and it will go. So actually it was here top. After pushing 13, top will be pointing to 13. After 24, it will be pointing to 24. After that, it will be pointing to 11. Now it is pointing to 30. Right? So top position was changing like this. Now top is pointing to 35 and the peak element is 35. The element pointed by 35. What will happen if I try to push 51? If I want to insert 51. Overflow condition raises. Why overflow condition raises? Because top is pointing to the last element of the stack. Right? This is the condition where we see this overflow condition. Alright? So let's look at the deletion operations. We've seen all pops, push operations. Let's see pop. If I remove pop, if I perform pop, that is a deletion, 35 will be removed. How can we remove? Just decrement the top index value. Now top is pointing to 5. Decrement it. Top will be pointing to 4. Always remember, if you traverse the stack, it will be from 0 to top. Index value is 0 to top. Right? So now top is 11 and the peak value element is also 11. So the element pointed by top is the peak element. So I'm going to pop 4 times. So I have removed the element at index 4, 3, 2 and 1. After removing all the 4 elements, 4 pop operations if I do, my top will be pointing to the element at index value 0. Right? Which is the element 21. Now the peak element is 21. Okay? Again pop. What you have to do? So if you remove 21, that is the top, if you decrement that, and top will be minus 1. So what do you mean by top minus 1? It says that the stack is empty. What will happen if you try to perform again a pop operation? Underflow condition raises. Why? The top is pointing to minus 1, which itself says that the stack is empty. What will happen if you try to remove an element from an empty stack? Underflow condition raises. So these are the few operations on stack. I hope you understood. Then what are the applications of stack? There are numerous applications of stack. I hope you remember the concept of recursion. Right? A function calling itself. Right? A function calling itself. So when a function starts calling another function, so for example, function 1 is there and in due course of its execution, it has called for function 2. Right? So this call will raise to a break in flow of control and it goes to execution of function 2. Right? So once the execution of function 2 is over, it will go to the function who have called it. Right? The control goes again to function 1. Then in this process, when the compiler compiles this one, when it want to do this, to which address it is supposed to go. So before leaving function 1, the control stores the location where it is supposed. Suppose this is a location 2000. It stores that address in a stack. It stores the address in a stack. So here when function 2 tries to return to function 1, it first goes to the stack, fetches the address and then goes to that location where it will again join function 1 for further execution. That is one of the basic, most important application of stacks for functions execution. Functions execution in any programming language. Stack is an internal part of any system. It is a structure in which data is stored, and the basic purpose of that is for functions execution. Okay, and numerous ways are there, and one of the advantages of your stack is it automatically cleans up the objects, not easily corrupted. Why? Because you don't have access. Anyone who is working with stack doesn't have access with all the elements. They'll have the access with only the topmost element. So data inside the stack cannot be touched easily to manipulate, right? So it is not that easy to corrupt the data in any stack. And the variables cannot be resized. Once they are pushed, they cannot be resized. Why? We do not have access to them, right? So these are the basic advantages of your stack, right? Advantages. Then what are the basic disadvantages? As we were learning till now, n value. What do you mean by n? Size of a stack, right? The stack memory is very limited. Random access is not possible. That is, not providing the access to the elements other than the top element is a boon in disguise, I can say. Why? Because security will be there. Anovis cannot disrupt that data, corrupt that data. That is very important. But on the everything have the other side of the coin, right? So if someone wants a random access, if we are using a data structure like stack, you cannot have that, right? You cannot have that. So whenever there is an application which needs random access, then stacks are not advised, or not the data structure that is advised to use. Okay, and variable storage will be overwritten. Okay, so it may lead to the undefined behavior of a program or a code or a function, right? So and one more thing, storing too much of objects will frequently raise the risk of overflow, right? So stack, whenever you use a stack, use for the applications which needs that structure of storing the data. That means cases or applications where you need only the most recently used data, you use a stack. Okay, it is not a data structure which is used for ordinary purpose. Okay, so these are the basic disadvantages of a stack. Coming to the applications. The best application is, as I said, the last not but the least one is a recursive application, function calls. And the one important application of stack is a conversion of an infix expression to postfix, prefix, any way of algebraic expressions. Say A plus B, where A and B are two variables and plus is the operation. This operation is known as infix operation. Why? Because operator is being placed between two operands, right? So this is infix. Coming to prefix, in which operator is placed after that the variables are placed. This is prefix, means prior to the operands, operator will be placed. Postfix, after the variables, operator is placed. This is postfix expression, right? All these kinds of expressions will be used internally by the system for evaluation of arithmetic expressions, right? So stacks are used for the conversions. Guys, we know only infix. How we write? If I want to add 5 to 4, I'll obviously write 5 plus 4. Have you ever seen any person writing plus 5 4 or 5 4 plus? No, right? We are using in generally. Or we can take an example, say a system works with binary number system, right? A computer works with binary number system. That means it understands only zeros and ones. And we humans understand only decimal number system. Have you ever seen any person writing 011, 00011, blah, blah? Right. The same I wanted to say. We know only infix expressions, but system does not understand infix expressions. Why? Brackets. Brackets are the drawback, right? So it doesn't know anything about that. So it converts them into postfix expression and then evaluate. Prefix expression and postfix expressions are free from brackets. Prefix and postfix are free from brackets, all sorts of brackets. In the coming classes, I'll tell you how an infix expression can be converted into prefix as well as postfix expressions. Okay. So for all these purposes, we need a stack, right? Then once the given infix is converted into prefix or postfix, then it will be evaluated. What I mean to say is, suppose I want to do 2 plus 3 minus 4, something like this I want to do. So this is an infix expression. System does not understand it. In the first step, it will convert it into postfix. How? Using a stack. Then it will, in the second step, it will evaluate the postfix. Whatever the resultant we got, postfix using stacks. Even for that, it uses stacks. Right? So even for that, it uses stacks. It evaluates and gives us the result. As the result of that above 1 is 1. So 2 plus 3 is 5. 5 minus 1 is 4. Right? So internally, evaluation of any given algebraic expression will be 2 steps. One is conversion of the given expression to postfix. Second step will be evaluation of that postfix expression. Okay. So for both these 2 tasks, we need stacks for internal storage. Next important application of stack is parenthesis balancing. Let's take an example. I have opened a flower bracket over here. After due course of few lines, I have opened another one. Due course, I have opened another one. After few lines, I close this compound. I close this compound. I close this compound. Got it? So have to check compiler. It is the job of the compiler, right? It checks for the syntaxes, right? So whether it is right or wrong. Yes. Here it goes. Stack. So the first flower bracket, it is going to insert. Open bracket, it inserts. Right? So again, after few steps, an open bracket insert. After few steps, an open bracket insert. After few brackets, a corresponding closing bracket it encountered. So remove this one. Now top is pointing to this one. After few statements, again a closing bracket. So remove this one and point to the opening bracket at 0th index. Last line, last statement is your closing bracket. So a corresponding one for this one is also found. Remove it. So after removing all the elements, top will be pointing to -1. Very simple. After the analysis of the code, if parentheses are balanced, means your top is pointing to -1. If top is pointing to -1, after going through all the brackets, means whether it is opening bracket or closing bracket, if top is pointing to -1, then that itself tells us that it is a balanced parenthesis. While writing a program in C, you might have encountered, when you were in your earlier stages, you might have encountered this problem many times, right? Missing parenthesis. So how it does? Using stacks. Very simple. Stack is a very beautiful data structure which is used tremendously in many areas while performing arithmetic logic operations or execution of functions or returning from a call function to a calling function. Anywhere they use stacks. Why? Because the beauty of the stack is it doesn't allow random access. It gives access to the element pointed by the top variable, right? So the last application will be depth first search in a graph. In any graph, if you want to reach from a source to a destination, right? So this is the destination and this is the, So if this is the source and the destination, so depth with the minimum number of intermediate nodes from source to the destination. If you try to go, you use a stack for that purpose. So when we deal with the concept of non-linear data structures, which are graphs, I'll explain you this concept with an example. Depth first search. Okay, guys, I hope you understood the introduction of stacks. So stack is a linear data structure where the data is stored in continuous memory locations, but access will be given to only the topmost element, whether you want to insert or delete, that is push or pop. You can perform this operation only with the most recently inserted one only. Okay, and overflow and underflow are the conditions which we need to take care of using isFull and isEmpty functions respectively. Okay, and you have seen the operations that how we are going to perform on a stack, and it is having a huge weightage in working style of any computer, whether it is evaluation of expressions, anything you take, right? I hope you understood this session. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.